So let me share my screen and we'll kind of bring us, actually, before I do that, let me close everything else that I'm doing here, just because I am going to do my full screen sharing. So I don't want to share anything that I shouldn't be here. So hold on. All right. So we've got our auction app here. And I basically only made 2 changes since where we left off on the last video. So the first one was in this auction RS file, I replaced the word token with my actual API token. And I'm going to try to not show you that, so I don't show you my API token, but I just did that so we actually have permission to communicate between our different components. Probably in a little more of a production environment, we'd want to load that from like an environment variable. And we could actually feed that environment variable into our worker. But I figured if I was going to do that and I was going to create the worker with the CLI app, then you would just still see the the token there. So I will just try. I have just replaced that. But all that is a copy paste. I'll try not to show you that, but I will show you how you can find your own token for when you do that. This is just dependency updates. And then the one other thing I've done for myself, again, because it's sometimes easy for me to shoot myself in the foot with command line applications, is I've just made a little bit of a cheat sheet for myself of kind of the different commands we're going to go through. And I think all of these are basically the same thing as on that Golem Learn website. And maybe we can go there for a minute when we get to that, and I'll kind of show you the example if you haven't already seen it. But I just find it's easy for me it's very easy for me to make typos, especially when I'm just kind of doing this in like actual like kind of terminal application. I think probably in bigger picture, this is going to be very good if you have things like CI where like, okay, this is code you're committing and you do it once and you get it right. But at least for me, kind of working with a terminal application kind of live, when it's not just like git push or something like that, it's easy for me to make mistakes. So I created a little cheat sheet here. But so just to kind of go over the architecture of our application before we work on actually deploying it. What we've got here is we've got basically 2 different types of workers. And at least so far, I've gone with the approach of being super modular with these 2 workers. And so there's essentially no code that's shared between them. They have their own domain models. They have their own WIT files, which, remember, this is like the protobuf of this world. They have their own logic. And so you could think of this as like a very microservices architecture in a way, where you could think of this auction registry is one microservice. This auction is another microservice. This happens to be a microservice that's basically going to have a lot of different replicas, you could say. There's going to be one for each individual auction. But I think microservices is in a way not a bad analogy for thinking about these. And you have that same level of like isolation right now of we could even go, and I think maybe for next time, a fun thing would be to see like we don't have to use Rust, and maybe we'll take one of these and we'll rewrite it in a different language, and maybe we'll do it in like Python or Go. Maybe Python, because I feel like I have slightly more confidence in my ability in Python, though both of them may be somewhat embarrassing for me. But yeah, we have that degree of separation there. And then right now, I've just got them part of this overall workspace here. So I've got that. And then maybe let me share my whole screen here. Let's do share. So I've got that. And then the other thing I've got here, let me just close all my other windows, is I've downloaded the latest version of the Golem CLI, and I've got that here for us to work with. Okay, so basically what I want to do now when I want to deploy my application is I'm going to want to build an actual WebAssembly component for each of my types of workers. We're probably going to be calling these worker templates actually in the future. Right now, you'll see it's component, but I think worker template is maybe a better way to think about it. So we're going to be building each of these worker templates. We're going to upload them to Golem so that Golem knows what an auction is and what an auction registry is. And then we'll call a couple of methods, and then we'll create one of the auction registries in particular, because in our architecture, we only need one of the auction registries. And then we won't create the auction ourselves. The auction registry will create the auction. And so we'll just call one of the methods on the auction registry, this create auction method, and it's going to create one of the auction workers, and it's going to give us back the auction ID, which is actually in this case going to be the worker ID for the auction worker, and that's going to let us communicate with that worker, and we'll be able to like bid on something or check on the status of our bid. And obviously, this is all kind of in the terminal application, so it's not necessarily going to be the prettiest, but hopefully, what you see from this is like the functionality. Where if you were building your own, say, website for the auction and you had your like front end, this would be, you could call these different methods using the REST API, just like we use to communicate internally between these workers right now. And you could use the results of these to feed back into the interface that you're giving the user in a prettier way than the outputs we're going to get here. So what I'm going to want to do is I'm going to want to build each of my workers. And one thing that I've found, and I'm not sure if there's a workaround for this, or I'm just not kind of doing this the right way, is when you have an overall workspace here. So you'll see here, this is a workspace, right? And it contains these two different things. And the nice thing about that is if I do something like cargo component check, it's going to check the validity of both of these workspaces. So that's really nice. But what I've found is, I think normally with cargo, if I navigate into one of these subfolders and I just build that, it'll just build that, the target for that sub-project. But I think with cargo component right now, if I do that, it just builds this top level thing, which I actually just want these two separate ones. I'll just delete these different target ones right here, just so we can see that. So to be able to do that, at least for the moment, I'm just gonna blow away these two, just so I can kind of go into each of them. And so here I've got my, oops, I think I'm already at the subdirectory. Oops, CD auction. You're saying way too much of my stuff. All right, so here, right. So I've got my auction and my auction registry subproject. So I can do either of them first. Let's maybe just do the auction first since it's alphabetically. So I'm going to go into here, and then I'm going to do cargo component build release. And so it's going to go through. It's going to pull all this stuff down. And so now you see it's created this target folder here, and then it's created this wasm32 wazi release, and this lib.wasm here. This is the thing that I want. So what I'm going to do, just because I'm very simplistic here, also close that, is I'm just going to drag that to my desktop right now. And I'll just rename that to auction.wasm, just so I know which is which. So, okay, I've got the component for my auction application, and the fact that this task succeeded says that they were successfully able to compile this into a WebAssembly application. So I'm going to go back, and then I'm going to go to my auction registry. And again, you could imagine like if you had like more of a script, you'd like automate a bunch of this stuff and do it together. But I'm just gonna do it all for us here as we're going. So again, I'm gonna do cargo component build release. Let this create its thing. Okay, and so I was in auction. Now I'm in auction registry. And I'm going to do the same thing. I'm going to go target, wasm 32, release. There's my lib.wasm. So again, I'm just going to take that. We'll move that onto my desktop right now. And I'll call this auction registry. All right. And now that I've got those two, I'm basically done with needing to do this. So I'm going to take these and I'm going to drag them in here just so I've got them handy. And let's go to this little README I created. And first, I'll just pull up the terminal and go to the desktop. Look up Golem CLI. Okay, so let's go back to these this little cheat sheet for a second. Let's go through these. So this first one that I'm not going to run for you, but you can run, is a token list. And this just shows all of the API tokens that you have. And I think for at least simple things, you basically, when you create an account, you have one API token. So when you get started, just that's your API token, you can use it. There's some more sophisticated functionality for you to create additional tokens, and you can give them expiration dates. So if I want to do something fancier, I could have maybe created another token and set it to expire an hour from now. So if you screwed around with my token while we were doing this, it wouldn't be that big a deal. But right now, I'm just kind of thinking keeping it super simple. I'm just going to quickly check in on the Discord and just see if anyone had any questions as we're going here. Okay, so Phil, I think you got kind of a much broader question, so I'm gonna come back to that either at the end of that or offline. All right. So yeah. So as far as the token, you can just run that yourself. You can find your token, and then that's what you would use in place of the quoted just that token word in the application on the GitHub. So I'm not going to do that myself. I've already done that. So the first thing then we'll do is we'll add the template for our auction. We got to add the template for the auction. We got to add the template for the auction registry. It doesn't matter what order we do them, but I'll, I guess, stick with the same order. And so for that, the API we use is we just do this component add, then we specify the name. I think I'm just going to call it auction one here. We'll see. Hopefully I haven't used that before for something. Otherwise, I guess we'll find out shortly. And then you just specify the path to the file that has the template for the component. And I made that simple for myself by just pasting that into the directory. So I'm going to go back to my terminal here. Maybe I'll just make this not full screen so I can go back and forth. All right, so let's give this a shot. So component add, auction one. I got my auction.wasm. It's calling this thing. Okay. So we got something here. And let me actually make this a little bit larger, so it's easy for everyone to see. How's that for everyone? Can someone give me a thumbs up, thumbs down? Okay. I'll take that as success. So you see we get some, so basically we get some metadata about our component here. So the first thing is this component ID or the template ID in the future, which is just basically UUID. So normally you shouldn't really need to use that. You can just use the name you specified. So like we'll see everything we're going to do with this auction one. But particularly if you use the REST API, sometimes you use the ID, which this is just like a totally unique identifier for it, versus you could have cases where maybe you have different workspaces you're working with and they each have different components and they happen to have an overlapping name. Then we've got the version of the component. So this is version 0. If we add further versions of this, they could be versions 1, 2, and 3. We get back the name we specified. kind of for our information, here's the size of our component. And then probably the most useful part for us is this thing here, this exports. And this is basically the API of our worker when we create one. So this says, hey, here are the ways that you can interact with a auction. And we had that initialize method, which remember we were using internally as part of our logic to just create the initial state of this auction. If this is kind of only going to be called, we only want this really to be called by us. So as long as we're not exposing to the outside world, that's fine. Otherwise, you might want to add some like validation here that like this can only be called once. Then we've got this bid method. And we can see we've got the signature here. So it takes a bidder ID, which is a string. And you can see this is even kind of, I think, useful syntax here of, and this is basically a JSON object here, but this has got also like the basically the format that we would use for that of it's JSON object with a field equal to each of the fields here. And then here's a type of it. And then we can do bid a price, we can include a price in our bid. And then we'll get back this variant, which you can think of as like an enum or an either, that in this case is going to be either a success that's not going to have any information other than it was successful, or it's going to be a failure with a string that has some details about why it failed. And then finally, we have this close auction that doesn't need to take any parameters and is going to optionally give us back the ID of the winning bidder. Okay, and so now our component, our template exists in Golem here. All right, so now let's do the same thing with the auction registry. So this time the component name, instead of auction one, I'll make this auction registry one. And I'll point this to the auction registry code. All right, so let me do this. Okay, and so see we got the auction registry, it's got its own ID, it's also version 0. It is apparently a little bit bigger, a good amount bigger actually than the auction. And we can see that it's got its own exports. And so the auction registry says, well, you can create a bidder, you can create an auction, and then you can get the auctions. So one of the things I'm going to do here, I think I already did this once, just when I was doing my little cheat sheet, but let's kind of doing it for ourselves, is this is kind of good stuff to, I would say, save for yourself, because this is the API for how you're going to communicate with this. So I'm going to go back here, and maybe I can make this smaller here. And so our first one was our auction component. And so at least for myself, I'm just going to go down here and I'm just going to drop this in here. So I've got this as we're going. Okay. So now we've got our templates uploaded. So now we're ready to create an individual worker that is based on one of these templates. And the one we're going to want to do is the auction registry worker, because that's going to be, we're going to create just one of those, and that's going to be responsible for creating the individual auction workers on demand as we make calls to it. So to create the auction registry worker, I'm just going to go to my little cheat sheet here just to help myself not make silly mistakes. Let's see. Oh, you know, we don't actually need to even create a worker because we can just call methods on it directly. And if it doesn't already exist, then it'll be created on demand. So let's do our first one. And so the first thing I'm going to want to do is I'm going to want to register myself as a bidder. And so when I want to call a method on a instance, if we go to the Learn Center, there are a couple of methods I can do. So there's basically one that's like invoke and one that's invoke and await. And the invoke you could think of as like fire and forget, of just like, hey, I want you to do this thing, but I don't care about the result, versus the invoke and await is like, hey, do this thing and then give me the result back when you're done. So that's the one we're going to do here. And then when you invoke a method on a worker, you say, what's the kind of worker that you want to call it on? What's the specific worker that you want to call it on? So here I just happen to have, I'm just happening to use the same name here, but I could use totally different names here. Then what's the function you want to call? And this is where it's really helpful to go back to that information you got when you created these, because this will have the exact signature and name of the method. So here I want to create a bidder. So I go down here and I see it's Golem component API create bidder. And some of this didn't need to be this way. I could have had different package names, so I didn't have the component or API, but this is what I happen to do in this case. So I've got Golem component API create bidder, and I've got component API create bidder here. And then finally, we have the parameters. And this is, there's a page about it on the Learn site, but this is a basically JSON-like format. So here it's going to be initially a JSON array where each of the elements of the array represents the arguments here. So again, going back to our signature of create a bidder, we can see we had 2 arguments. The name was a string and the address was a string. And so here, the array is going to also have 2 elements. And in this case, I'm Adam, and I don't actually live on 123 Green Street, but we're going to go with that here. So let's call this here. Okay. And so we can see this successfully completed. This also should be a little bit snappier in the next couple of weeks. We're moving to a version of the CLI that's based on Rust, actually, so it should be a little more performant. But we can see that this worked, and it gave me back a bidder ID, which is exactly what the signature promised to me, right? So it's going to give me back a bidder ID that's a string here. So I'm just also going to copy that here because I'm going to need that later. All right, so now we've got I'm registered as a bidder with my fake address. And now let's create an auction. So we're going to follow the same process. So we're going to specify the type of worker we want to call this on, the specific worker, the same auction registry one. We're going to specify the name of the function. And again, we're going to specify the arguments. And in both of these cases, the arguments have been pretty simple. They've all been primitive values. Of here, they've been strings. Here, they're numbers. So you can see, again, it's pretty straightforward. If it's string, you quote it. If it's a number, it's okay to just do a number. We'll see an example in a minute where we have a slightly like a record type that's like slightly more complex. But I think this is going to be pretty straightforward. So let's create our first auction. And there we go. So I've created my auction here, and this one there's a little bit more work that went on in doing this one than the previous one, because when we registered as a bidder, remember all the auction registry did was it just basically created a new bidder ID for us. It added it to its own internal data and it gave it back to us. So this was like very simple in the underlying implementation. This one, there was actually a good amount more going on here, because remember that when we call this create auction, what the auction registry is doing is it's actually creating a whole other new worker for the particular auction. It's initializing that worker. So it's calling a function on that worker itself to initialize it. with this information, and then it's giving us back this auction ID. So by the time we've got this auction ID back here, this is actually, as we'll see in a sec, this is the ID of the auction worker that is handling our auction. And we can use that ourselves to interact with that individual auction worker. So I'm going to grab that and I'll also paste that down here just so I can have all this stuff. And so now we're ready to, we can imagine, again, if this was like a real application with like a front end, like, okay, now we've got this auction ID. Now the user wants to do something to interact with that. Well, now we've got this auction ID that's a handle for further API calls to interact with that particular auction. And so a simple thing we might want to do is we might want to bid on that auction, right? And so again, we're just going to use the same invoke and await. Now the type of worker we want to interact with is the auction worker instead of the auction registry worker. And now the name we're going to give it is the name that we just got back. And then here we're going to want to bid. And if we go back to the signature of bid, sorry, bid right here, we can see it's looking for not just a string, but a bidder ID, which is basically a record that has a string field in it. And so the way we're going to specify that is just normal JSON, right? Of we just have the curly braces here, we have the name of each field, and then we have the field here. So again, I'm going to get, so I got my actual auction ID here. I'm going to scroll up, I'm going to grab my bidder ID, and I'm going to put that here. And so I think the limit price was 100, and I'm going to bid $200 here. Or 200, I mean, we have a specified currency, so we can assume it's whatever currency we want. All right, and this has not given us, this has just given us kind of an empty response, which if we go back to the API for this one, when we bid, we're either going to get a success with no information or failure. So we were successful in our bidding there. And again, that this is like, it seems like, oh, it's very like simple when we just like call it, but like this is kind of cool of we're now able to interact with this worker that we didn't create ourselves, right? This auction worker was dynamically created for us by the auction registry, and that's the auction ID it gave back to us. And now we get to interact with that ourselves. And we can imagine we can have thousands of different auctions going on, and most of our interactions are just going to be with the individual auctions. So we're going to have a very scalable system, especially if we put like caching in front of the auction registry when you like get the list of auctions, because it's going to be fine if that's a few seconds out of date and getting the latest auctions. So that's really that's really it. I think, I mean, in a way, like we went, I think, overtime the last couple of sessions because we're really doing a lot of stuff. And I think the nice thing with this is it actually basically just worked. I think I had some qualifiers of, especially as we were doing the HTTP calls for the worker to worker communication. I was like, oh man, I'm sure I've screwed something up somewhere, and we'll have to kind of go through and fix stuff. But everything actually just worked. So yeah, it's pretty cool. And again, you can do the exact same thing yourself. The code for the auction is on my GitHub. I think there's probably a bunch of like improvements we can do to the like business logic of like the auctions. But the nice thing about that is like that's all super straightforward. Like it's just code in Rust, or in the future it can be code in whatever language you're working in. It doesn't have anything to do with WebAssembly or with or anything else. So that's all super straightforward, and maybe I'm sure like at some point I or someone else will like push some updates to that, and we'll kind of add some more of that logic there. But you can do all of this yourself. I'll push this up with the little cheat sheet of these commands. But maybe let me stop this and let me do a new share just to show you where you can find some of this information if you haven't already seen it. So hopefully you've checked this out before, but this Learn section has a lot of great information. And Daniel in particular has been fantastic about adding a bunch of the stuff as he's been going and doing different things. But for the CLI, one thing I would recommend taking a look at is this quick start. It basically walks you through with a slightly different example. It's kind of shopping cart example versus we did this auction example, but it walks you through all these different commands. I see there's a question of will there be an easier way to communicate with workers instead of calling the REST API? Yes, that's something that is definitely coming in the future. So the REST API is kind of the way to do it today. If you want to get started, there'll be more stuff in the future to make that nicer for you. Anyway, so I think this is a really good resource on the different things you can do with CLI, as well as there's more information down here about specific commands. There's also information on the REST API here. And then again, already the code, except for what we've done today, is on my GitHub for this auction app, and I'll post those changes up so you'll be able to see that. And I think that will also probably be helpful, because I think even like the REST API, I think you saw it was like a little bit annoying us having to do it, and I think it will be that'll be getting better in the future. But also, it's going to be a lot less annoying if you've just got a kind of template you can copy and paste from for that, versus when we were doing it, we were kind of doing a little bit from scratch, though even that ended up not being that many lines of code. So definitely check out those resources. But yeah, I think I mentioned last time as well that we definitely want to have a simpler way to do worker-to-worker communication, and also a more strongly typed way. So I think maybe something you could think about there in terms of what to expect is, like, if you've ever worked with, I'll just do the kind of Rust example, but I think there are similar things in other libraries. So think about, again, the WIT file being like a protobuf file, and think about using a gRPC library. So a library like Tonic, or a library like ZOgRPC and Scala. And essentially what it would do is it would generate a quote unquote client for you based on a protobuf file. And then you could call that in a typed way. And so I think you could imagine having a very similar thing in the future, where essentially if we're the auction registry and we want to communicate with one of these auction workers, we would essentially be able to depend on their WIT file, and we would be able to use their WIT file to automatically generate a, you call it client, or what exactly the perfect word is. But where having that, you could just do like worker.bid, and then you would just specify these again in a strongly typed way, and that would just happen for you. I think that's probably the type of interaction that we'd like you to be able to have there, where it's very simple and strongly typed, and it doesn't have boilerplate associated with it. Okay. Does anyone else have any questions here? Okay. Well, great. So let me maybe try to cover some of Phil's questions, because I think they do get to maybe some of the like underlying things about like kind of how Golem works and what it does, and like the guarantees of what it means to be invincible or durable. So his first question is, if the actor crashes after the start of handling, so hold on a second. So I see Yuri's got a question. So maybe let me just see if I can cover that because that may be simpler. Can you tell a bit more about moving workers between different machines? Sure. And let me, hopefully I'm understanding your question correctly. So, and it's actually, I think in a way relates to Phil's question. So when we're interacting with these workers, like, right, we were just calling the auction registry and we were calling the auction, and they were running on some server that Golem is maintaining somewhere that right now lives on Amazon, but in the future might live on Google Cloud or Azure or your own private cloud or wherever. But basically there's some server that's running this thing. And the whole idea of Golem is that if that server gets blown up for any reason as we're doing these operations, as we're working with this stuff, that's no problem. And in fact, that should basically be, we shouldn't even notice that because things should just pick up immediately where they left off on another server. And so basically to walk through a little bit more about what would happen there. So let's say our worker is initially running on server one, and then server one falls over for whatever reason, right? Maybe there's a hardware issue on that. Maybe as part of Amazon's normal maintenance, they've like taken that one down. Whatever's happening there, that thing is down. So at that point, Golem is going to observe like, hey, the server is no longer functioning. And it's going to take all of the workers that were previously the responsibility of that server and allocate them to other servers on our network, possibly existing ones, possibly spinning up a new one. And at that point, this is really where the resiliency of Golem comes in. We're going to look at that worker, and we're in particular going to look at our record of everything that worker has done. And this is where like WebAssembly and the sandbox environment becomes very powerful, because in WebAssembly, every interaction your program has with the outside world has to come through capabilities that we provide to it. So even though we're doing these relatively high level things of like, we're making HTTP calls even, all of those HTTP calls, everything you're doing is ultimately compiling down to a set of probably less than 20 capabilities that are provided to a program as part of WASI in the component model. So when you do anything, when you print to the console, when you generate a random number, when you get the system time, when you make an HTTP call, all of those things translate down into this base level of capabilities that are provided to your sandboxed application. And what we do at Golem is we provide our own versions of each of those capabilities that track everything your application does. So when you make an HTTP GET, we've got a record of you made an HTTP GET request, and here is the response that you got back. When you generate a random number, we've got a record of you generated a random number, and when you did, it was 43. Or you got the system time, and when you did, it was 10:45. We've got a record of all of that stuff. And so what that means is that when your program goes down on server one, and server two now is responsible for it, the first thing it does is it looks at that record of everything your program did, and it uses that to bring your program back to the same state that it was at immediately before it fell over. And conceptually, you can think of there are kind of two ways you can do that. One is we just apply each of those changes to your program. The other is we do like smart snapshotting, where we say, okay, at this point, we know the state of your program was exactly that. And we use a combination of those for efficiency. But the takeaway from that is that the first thing server two is going to do is it's going to catch your program back up to the state it was at immediately before it fell over on the previous server. And so what you're going to see there when that catch up is done is your program is going to have the same state that it did previously on server one. It's not going to redo any of the external interactions. So if you made an HTTP GET request before and you got something back, you got the number 43, we're not going to make another HTTP request. We're just going to keep track of the fact that you got 43 last time, and we're going to feed that into your program, because everything in RASM is deterministic except for these capabilities we're providing. So the first step is we're going to bring your program back to exactly where it was, and then server 2 is just going to continue with the execution. So if there was another step the program was supposed to take, right, it was supposed to do A, B, and C, and it fell over after doing B before doing C, then once it's got caught up with A and B, it's just going to go on and it's going to do C. And maybe then it's going to get another call and it's going to do D, E, and F. And so that's why I can kind of interact with this program. And yeah, maybe even as we were speaking, I was blabbing on too long, and maybe I did my first call and it was on server 1, and I did my second call and it was on server 2. I'm not even going to know that. And that's really the promise of Golem. Okay, I see there's a follow-up question here. Does this memorization, I don't know how to call it, behavior better, include there's basically, I guess, a question of these like transient requests, and so that's really part of your application's logic to handle. Even if you make a request now, it could take a indeterminate amount of time. So by the time you get it back, something may already have happened. It may already be out of date. So there are definitely, I think, cases where you might want to apply different logic to that. But the idea is really that we should be able to pick up your program from wherever you left off if you fell over. And that's what really gives us this property of like you not having to worry about like all these intermediate points of failing. So Kama has a question of, well, Andres, that's a lot of data to keep track of. So that's where it's not actually necessarily that much data to keep track of, but that's also where this idea of snapshotting comes in addition to kind of keeping a record of, well, you started with 0 and you added 1 and then you subtracted 5. I can keep track of all those steps, or at a certain point I can just say, well, okay, at this point I know the number was -4. And I can carry on from that point as long as I've got the state of the application. So we use a combination of those to achieve the most efficiency that we can. I don't know if there's a plan to add support for not recording things. Not snapshotting things. I think we will eventually definitely add support for kind of forcing a commit at a certain point. But I think that's definitely something we could potentially look at. I think this is definitely, we're obviously early in the process of developing this and sharing this with the world. So I think one of the things we're excited about is to see what applications people build with Golem. And I think as we do that, even just in the process of building this auction application, right? I think we saw that worker communication is very important, and we want to make that easier. And so I think we'll see more things in the future where we can add additional functionality. Okay, awesome. Yeah, I think those are really great questions, and yeah, it is one of those things where it's a little bit of our secret sauce, but also like conceptually we want everyone to understand like how it works and what it's doing and what the guarantees are it's providing. And I think maybe we tried to do that in the first session, but I think maybe there were just so many concepts flying around with like WebAssembly and WID and all this stuff that like it's easy to get lost there. So I'm really glad we were able to cover some of that stuff. Okay, well, despite this supposedly being a shorter session, we're actually not too far away from an hour here. Let me give maybe one more chance if anyone has any questions, and we can definitely do it offline, and there's the Golem Discord. So or I'm sure we'll be back next week and we'll do like Python or something. So this is not your last chance to ask questions, but if anyone does have any other questions now, we can definitely cover them, or otherwise I can let folks enjoy their weekend. Okay, I see. How can we contribute? Okay, that's a really, really fantastic question. So the thing that's different about Golem from some of the prior software that I've worked on is it's not entirely open source, right? If people kind of know me, the previous thing I worked on, Zio, like everything was open source, and that was great in its own way. This has a kind of proprietary component of the Golem Cloud, but there's actually a lot of opportunity still for like building the open source ecosystem around this. And so the first place I would encourage you to go is there's a Golem Cloud open source repo, and there's actually already a bunch of stuff there. Daniel has been great about, he's added their versions of several of the supported languages that have kind of all the right versions of the dependencies. So that's really good. In addition to that, there is a Golem templates repo. And so that's actually where I think I demoed this last time, and maybe I can do it here. Let's see, new share. Oh, maybe I got rid of my terminal. Oh, here we go. Let me just do new share. Okay, so let me see. I'm terrible about these CLI commands. So okay, list templates. Okay, so you see that with the CLI, I just did this list template, and it gave me a whole bunch of different templates. There's basically one for every language that we consider having kind of full support for the capabilities that Golem needs. And in a lot of cases, there are more than one of them that kind of demonstrate different features. So like in Rust, we can do like a actor example of lots of stuff, including calling HTTP endpoints. We have a minimal actor that has no dependencies. We can have a hello world in Rust. We have a shopping cart in Rust. We have a to-do list in Rust that Terry added. So all of these are things that you can, basically with one more command, you can download that whole shell yourself, and you can use that as a point for getting started. So I think a really good way you can contribute is you can create your own app for something you think is interesting or useful and contribute it as one of these templates here. I think probably the auction application at some point will kind of clean up, and we'll try to get that in here, and maybe we'll try to make that be kind of our like cross-language example. So we've got something that is like not too minimal that people can look at that actually does some stuff. But I think definitely like, you know, we maybe have some creativity. All of you have like a whole other level of creativity. So it would be really great to see what you kind of come up with there. I think the other thing that's going to be super valuable in the future is more language specific kind of tooling to make things easier to do. So like if we go back to our application here, so I think actually probably Yuri commented on this like a while back. Like we have this model file, and we kind of have these two different data types. We have like the kind of business logic data types, and then we have the WIT data types. And in Rust, we use these from and into traits to, I think, actually overall make it not very painful to go back and forth between them. But I think even as we were doing it, he said like, hey, this is something that would be like ripe for automation. And I can totally see that being the case. And I think some of that stuff is going to be like language specific, right? If there's going to be like a different way you like auto generate like your types from the WIT types, or you generate WIT from your trait for Rust versus Scala versus Python versus JavaScript. And so I think that's a really good area where if you have a particular language you're excited about, you know, you're like, hey, I'm a TypeScript person. Like, you're in a fantastic position to think about what tools could make it easier for us to all collectively develop these applications in TypeScript and kind of cut out some of that boilerplate. because there's probably some of that we're going to be able to do as a Golem team, but there are a lot of different languages, and we may have to prioritize and say, well, most people are doing it in language X, and so we'll spend some time on X, but maybe you're using language Y, and maybe there are a bunch of people who are using language Y, and it would be really nice if there was some tooling there. So I think that's a big area that it would be fantastic if people got involved with. And I think if you are interested in that, I think reach out to me or reach out to Daniel, and we can probably kind of give you some feedback there and maybe try to like structure something if that is something that you want to really put some time into. Yeah, but really good question. Okay, and I say there's one other really good question I want to hit on. So I understand golems can run for a long time, but how does that work when new version of a golem work is deployed? Does the old version keep running, or is it replaced? Yeah, so one of the things that's going to be coming is a functionality for what you call hot upgrades. Because you're right, that there's something just different about Golem workers than other tools like this that we've had before, that if you think of like a AWS Lambda or something, it like runs for 15 minutes. So like if you need a new version of Lambda, then you just like basically just create new code, and 20 minutes later when you call it, you'll call the new versions of the old version, and that's fine. Versus if this worker is around for months or even years, like there may be a need for you to fix a bug or upgrade it. And so one of the things that we're going to be working on adding is this functionality for what we call hot upgrades. And we think there's probably going to be two ways to do it. There's kind of going to be like an automatic way and a customized way. And the automatic way is going to work if your changes are what you could kind of think of as either like forward compatible or relatively minimal, where essentially your application would have the same state up to today, and you just want to do something different in the future, then we can just kind of patch that code there for that worker. And then the other one would be more customized of if you kind of need to make what you think of as like a backward incompatible change. And that's going to be supported by a functionality where you basically specify a custom way to export your application state from the old version and import it into the new version. And then when we do that customized upgrade, we would take everything out of the old version, put it into the new version, and then carry on from there. And again, that would kind of give you like full flexibility around that. So really good question. And I mean, definitely something that we want to have in the future as we have these longer lived workers. Okay, well, with that, I think I really am going to call it here. But again, thank you so much. I think this has been like a really fun set of sessions, getting to something that is definitely closer to the real world. I think next time we'll try migrating one of these components to a different language. I think maybe Python, and I think that will be fun too, and we'll be able to see that like how much of this is like not Rust specific, how that was just like the language we were happy to use versus the language that we had to use. Okay, I see Gurchin typing. I'm going to give you 1 minute here before I call it for real. Okay, just thank you. All right, so thank you for all of you, and have a wonderful day. All right, bye.